All right, so for these sections, we're going to talk about the graphs of the sine and cosine functions, and then going on to the other four ones as well. Well, first we're just going to talk about, how do we graph the sine functions in the xy plane? Okay. Now, when it comes to it, so our portion is going to be from negative pi to 2 pi, right, when it comes to it. So essentially what we really want to do is just make a t-chart where the x's are between these numbers. So negative pi, right, we'll just go around the circles. So negative pi over 2, 0, pi over 2, positive pi, 3 pi over 4, and then finally 2 pi. So if you wonder where I'm getting these numbers from, is if you go to a unit circle, I'm just going around the complete unit circle on the axis, right? So starting from negative pi, so that's negative pi, 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi, right? Those are going to be our x values respectively. And now what we want to do is, well, what happens when we plug in negative pi into sine function, right? So again, we're just going to go around the unit circle. So at negative pi, we're over here. So the y value is 0, so that's going to be 0. At negative pi over 2, which we're down here, so the y value is negative 1. And that's how we go about doing it. And we just go about completely in the circle format. So at 0, the y value is 0. At pi over 2, the y value is 1. At pi, the y value is 0. And almost done. At 3 pi over 2, y value is negative 1. And then finally back to 2 pi, where it's again 0. So that's how we do the t-chart using the sine functions. And now all we're going to do is just simply graph them. All right, and now these are our points, right? So negative pi, it's 0. Negative 2 pi, it's negative 1. 0, 0. 2 pi is 1. Pi is 0. Negative 3 pi, positive 3 pi over 4 is negative 1. And then finally back to 0. And now we're just trying to connect it as a nice smooth curve as possible. And there is our sine function. And so these go on for forever, right? These go on here and here when it comes to, but essentially just oscillates going in a loop when it comes to it. So that's how we, graph. So basically, this is how we're going to graph all the trig functions, believe it or not. It's as simple as just a t-chart and literally just going around the unit circle itself. Okay. Now, a couple properties when it comes to it is the first major property is domain. So when it comes to the sine function, right, domain is all real numbers. Right, because it's the entire x values that are always true, right? So you can plug in any x value, we're going to get a y value out. Okay. When it comes to the range, however, so if you notice, the ranges are the y values, right? So it actually does not ever cross 1 or negative 1. So the range is literally from negative 1 to 1, including it. So all the numbers between those two numbers actually work. Okay. We talked about this earlier. Sine function is even. Or sorry, let's talk about even odd. What am I talking about? Cosine is even. So sine is odd. And now finally the period. So period we'll talk about in a little bit is basically how long it takes to go one complete revolution around the entire unit circle. So this actually ends up being 2 pi. So if I start here, right, you can think of this as if I just attach these two together, so if I just glue this part over here, I get one circle. That's what it means by a period, is how long does it take to go to one whole revolution of a circle, and it takes 2 pi when it comes to it. Okay? So that's sine function. And believe it or not, we're going to do the same exact thing for the cosine function up here. So just do a little t-chart and do the same thing. So use the exact same values. So again, from negative pi to 2 pi. So negative pi over 2, 0, positive pi 2, pi, 3 pi over 2, and then finally 2 pi. And now this time we're going to use the x value. So again, remember cosines x values, sines are y. So negative pi, that's going to be negative 1. That's the x value, correct? That's the sine, cosine. Over here, x value is 0. At 0, x value is 1. At 1/2, x value is 0. So notice they're kind of opposites of each other, right? At pi, it's negative 1. 3 pi over 2, 0. And then back to 2 pi is 1. So we should have this as our t-chart there. Okay. And now we're going to do the same thing. Just make a little t-chart and plot them. Okay, so now this time we're going to start with negative pi and negative 1. So this starts actually down here this time. Okay. Negative pi over 2 is 0. 0, 1. Pi over 2, 0. This is going to be negative 1. This is 0. And then finally we go up to 1 again. So it kind of looks like this. Like that. So it's very similar to the sine function, right? So let me get our sine function out. So it kind of looks like that. Notice it's just a little off, right? Like it starts a little bit like tweaked when it comes to it. And we'll talk about, what it means by, how these simplified sine functions and cosine functions almost look identically the same. Okay? So that's that portion. That's pretty much it. Okay, so it's pretty straightforward, right? All we're doing is going around the entire unit circle based off what the unit circle tells us, what the x and y value is going to be for each case. So the good thing is the properties are almost identically the same. Domain is, again, all real numbers. The range is still the same, right, because it doesn't go any higher than 1 or negative 1, so it's bounded between 1 and negative 1 including. Okay. In fact, the only thing that's different between sine and cosine is this is an even function, and that's it. Right? Sine is an odd function. Period is still the same. 2 pi. So this is a little weird to look at, but like if I just do that, right, it's kind of like a quarter circle, half circle, quarter circles, right? So if I like glue them back together, you get one whole circle in the middle, but that takes a whole of 2 pi to get to that whole part, right, when it comes to it. So remember, it doesn't have to be perfect, right? It can be parts here, parts here, parts there, but if at that point, if I cut it off here, and if I just glue the pieces together, I do get a circle. So how long does it take to do that is 2 pi. Just like the last one, it took 2 pi to do that portion. Okay, so that's what we mean by when it comes to period. And again, we'll talk about a little bit more of that in a little bit as well. Okay, so what we're going to do now is, well, the good thing is a lot of this times is, we talked about, transformations, given the parent function, how do you move this, do that, things like that. And the same thing applies to sine and cosine, believe it or not. So let's just look at this example here. Now let's graph 3 times sine of x. Okay, so what we're going to do is just do the same thing. We'll make a little t-chart, and then we'll just go from 0, let's say x, to 2 pi. That way it's not as large when it comes to it. So we'll go 0, pi over 2, pi, 3 pi over 2, or sorry, 3 pi over 4, and then 2 pi as our x values. Okay, and now all we're going to do is plug it in and see what we get out, right? So plug in 0. So when we plugged in 0 for sine, so we plugged in 0 in for sine, we got 0 out, and then 0 times 3 is still 0, right? Sine of pi over 2, well, sine of pi over 2 is, we got 1, right? So 1 times 3 gives you 3, Sine of pi is 0 times 3 is 0. Sine of 3 pi over 4, we got negative 1. So negative 1 times 3 is negative 3. And this ends up being 0 again, right, when it comes to it. So let's graph this and see what's actually going on here. So 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Okay. All right, so at 0, it's still 0, so start here. Now it jumps to 3, though, however, right, when it comes to it. So goes to 3, 1, 2, 3, so this goes up to here, and then it goes back down to 0, and it's back down to negative 3, so this goes all the way down here, and then it goes back there. So if we make our graph now, it looks like that. Okay. Well, it's very similar to what we had earlier, right? This is the sine portion. However, notice this one only went up to 1 and negative 1, but now this one goes up to 3 and negative 3. So what we want to figure out is, again, just like the parent functions, is there any way we can, associate some stuff given our parent function and just do a quick transformation because of that? And if you notice, right, all we really did from our basic function to this one is just multiply by 3. Everything else is identically the same. So in general, we have this a out there. We'll call it capital A. And the good thing is this works for both sine and cosine. So in general, when you have an a value times the sine or a value times the cosine, all you're really doing is tweaking the y values themselves, or stretching it, right? Stretching it up and down. So essentially, if this a is, you multiply the a value to the y coordinates when it comes to this transformation. Nothing changes to the x's, right? Which is the nice thing. Right? So the key thing is, right, so whenever you have a number in front of a sine function, when it comes to transformations, you're literally just multiplying from your parent function to your child function just by y. Literally just multiplying. So there's no adding here. It's just straight up multiplication when it comes to it. Okay. So